Hi there, Christopher here, and today we are in Kerbal Space Program Realism Overhaul, and we are looking at launching or test launching a satellite for a 9-satellite communications constellation that I have developed using mathematics. If you'd like to see more of the mathematics, just hit me up and I might make a video of those. So today we are just going to be launching one of these satellites just to make sure that it can get to the correct orbit and all of that fun stuff. It is going to be launching aboard a Delta II with what is shown right now as the Delta II upper stage and the satellite right here. And so without further ado, let's make sure that all of our staging is in order. First we're going to have the launch. And we're going to let go of the umbilical cords and launch clamps. Then the boosters are going to separate. Then the upper stage is going to separate. Okay, so that looks correct. So here we are on the pad, and you might notice that this particular rocket has 4 boosters around one central core. Now this was done mainly to give it more thrust to weight ratio off the pad so that it could get going faster off the pad. So we're going to check out some of the statistics here. We're going to be aiming for a 409 kilometer orbit, although I'm not expecting us to get to a 409 kilometer orbit. We're going to hit engage autopilot, hit space to fire up the rockets, hit space again to release the launch clamps, and we are off, ladies and gentlemen. So at the bottom here you can see our speed relative to the surface. You can see the nav ball, which tells our orientation and rotation. At the top here you can see our altitude readout and our vertical speed readout and our what layer of the atmosphere we're in. And off to the side, these two windows here kind of show us where we're at in the program that I wrote for this. I'm using MechJeb for this, but what settings I have for the autopilot, and we can kind of see what the rocket is doing. So it's currently pitching over to start building up some horizontal speed because we are going past suborbital into an orbital track today. We can see our solid fuel is nearly out, and there go the boosters. And let's check. Okay, so we have frozen the pitch program. The rocket's going to wobble just a little bit. That's because I didn't get my programming perfect this time. In a real rocket, you would not want to see that though. Let's wait for it to settle before we reanalyze stage analysis. And now we are in peg guidance. So this will be the final guidance that will take us all the way to orbit. We are in the real world, this is called apogee, so we'll call it that. So we can check our apogee height, and at just over 300 kilometers, we're going to run out of fuel. And now we have deployed the second stage, or the upper stage. And we seem to be rotating. That's okay. So this rocket will actually be spin stabilized. This is how some of the earlier upper stages and some satellites like Galileo stabilized, and you can imagine it like throwing a football. If you spin it, it's more stable. Same exact concept, but with a multi-hundred-ton rocket. Okay, so we're just going to coast up here. We're almost at 400 kilometers. We can check our time to apoapsis. That's going down. That's an okay thing though. Our perigee, instead of apoapsis, it's apogee, and instead of periapsis, it's perigee. So our perigee is currently negative. So if we were to shut off the engine right here, we would fall back to Earth. Now the name of the game is building up enough speed here in this kind of orbit window to get that perigee above the atmosphere. We can go 4 more kilometers per second, resulting in a total velocity of 7 or 8 kilometers per second, which is right about where we should be. You can also see that we've now deployed the fairing. I said that a little bit late, but you can now see the satellite. We have our primary dish, our omnidirectional antennas, our solar panels right here, the main satellite bus, and the solid rocket motor. Can also see, I believe that's Bermuda down there, because we just came off the Cape. That is Florida, and Cuba's over there. Yep, so now you can see that that number is starting to go down, whereas our perigee is starting to go up. So down, but since the number is negative, it's actually going towards 0 and eventually up. So we're actually going for an initial orbit here, and then we're going to try to burn this rocket engine again to get to a transfer orbit where we can release this satellite, have it fire its solid rocket motor at a very specific point in time to get from the transfer orbit to the final orbit. And then this upper stage will eventually have its orbit degrade, and it will eventually fall back to Earth and burn up in the atmosphere. On this window right here, we can also see some pretty interesting stuff like our aerothermal flux. So that is how much electricity is being built up based upon based upon what level of the atmosphere we're in. It's currently just over 1,000 watts per meter. And we just changed something here. Oh, we just changed to locked terminal guidance. So that is going to be our final orbital stage that will carry us all the way there. Okay, so we are now speeding up time until we get to our maneuver node. And we are now in orbit at 418 kilometers by 399 kilometers. Okay, so we can now take this down, we can take this down, and we can go to the map view. So there is Earth. Here is our orbit line. So some of the white orbit lines are previous tests that I've done. And we can now zoom in here to our perigee and make a maneuver at our perigee. So our transfer orbit is going to have an apogee of 2,339 kilometers. So we can just really quickly drag these prograde and retrograde markers down and up until we get that apogee where we want it. 4,312, 3,936, 3,863. We're getting closer. So what we're going to do is we are now going to speed up time again, except we are now going to have a goal of getting around to there. So we're now going to hit T for SAS. We're going to steer ourselves so that we are pointing in the right direction, and we can watch the sunrise also, because that is where our perigee lined up with. Okay, so we're now going to do a puff of monopropellant from the RCS thrusters to stabilize the fuel. Hit forward, and now we have an estimated burn time of around 28 seconds. which means that we actually need to start burning right now. So we're just conducting that burn. Now, what the monopropellant did is it kind of forced all the fuel to the back of the tanks and into the rocket engine. So we can just shut that down now. And we now have an orbit of 343. And from here we can, from our apogee, we can make a maneuver for our perigee to be, our current perigee is 399 kilometers. We want that to be 409 kilometers. So again, it's just going to be a case of messing around with the maneuver nodes, and so we're going to wait yet another orbit. And another orbit. And let me actually check something. So nothing is activated on this satellite. So that's why we weren't getting a connection. However, I think that if we just ignore this, doesn't require connection. Now, since this is a test, I can actually do this because I'm not actually trying to make the 9-satellite constellation. This obviously would not work in the real world, and I don't believe that it works here either. So that is our test satellite. I'm going to call that a success because we successfully put a satellite into a closely desired orbit. This is Christopher, and I'm out.